And I'm Gojko, this is Sige. We are going to talk about how do we actually know if something has quality or not, and what does that even mean? For lots of organizations, when I used to work as a consultant, I was consulting people on kind of software quality. The concept itself is very fluffy. It's something that people kind of don't really agree about. They don't even have a good discussion about. Lots of different people measure it in lots of different perspectives. And then there are massive disagreements whether something should be released, not released, and things like that. So a while ago, I was working with a client in finance, and we were trying to figure out how do we make this more systematic for them. And I came up with this model and wrote a blog post about it and completely forgot about it. And then Sigi told me that they used it at his place of work with kind of fantastic effect. And that's where the idea came out for this talk, where maybe we can help you create a model similar to that. So we'll show a couple of models. Don't necessarily copy any of these models, but maybe think about the process of coming up with those models and what that kind of model would look for your organization. That's the sales pitch for this talk. Can I go now?
Yeah, you're done. No. So we're going to make things tangible. And to start off, obviously, we need to have the mandatory introductions. I'm Sigurdur Birgisson. I have been part of the program committee for Øredev for quite a while. I've been working within software testing and software quality for the last 15 years. I've been working at some of these companies, IKEA, that's my current company, Avencia, Atlassian, J-Way, and Øredev. And I'm originally Icelandic. You can't hear it from my accent, but I've lived in Sweden most of my life. Yes. And so this image, I just want to share. It was an amazing way of understanding how users that have visual impairments can see the world, because we're doing a lot of work with accessibility at the moment. So just putting these glasses on and trying to see what is on a website was a way for us to experience that. Okay. 2009, I invited Gojko to come to Øredev. Completely unknown guy. He's written a couple books, and he's been coming back quite a lot since.
Yeah, you can't kick me out even when you don't invite me. I come and take a stage and talk.
Yes.
So yeah, I'm Gojko. I've never worked for Atlassian or IKEA or any of those companies, but I'm really good at assembling IKEA tables. So if my software job doesn't work out and you need help with tables, I can do that. And yeah, normally I look like this. So that's it basically for my introduction.
So, and now we're gonna start off with a poll. So basically, if you take your phones out and scan the QR code here, we would like to ask you which of these options of your software would you ship to production? Would you ship 10,000 lines of code?
So this is after testing. We just need to explain. So we've done testing.
Is it after testing?
After testing.
Are you sure?
Yeah.
So 10,000 bugs in 10,000 lines of code, 1 bug in 10,000 lines of code, or 0 bugs in 10,000 lines of code. So scan the QR code. We're going to have have a look. Nothing. Refresh.
Ooh.
1 bug, 0 bugs. Okay, no one wants to ship 10,000 bugs.
Why not? So much bugs, kind of guys. That's a
6%. But and this is where you ruined it, because this one wasn't actually tested.
No, it was.
You were
tested.
just told by a report that it was.
Okay, so people, or no, it wasn't testable, So I think when you look at something like this, lots of people think about measuring bugs as a decent way of assuming there is quality or not. And I was kind of almost kicked out from a private conference where a bank invited me to speak about measuring quality, and then I was trying to point out that 0 bugs is a really stupid policy to implement. And I ended up arguing with somebody at the back who was insisting that that is like their strategic objective, and I was trying to explain how you can have something that is completely useless and has 0 bugs because nobody's using it. Nobody's noticing anything with that. And how you might have stuff that's like, totally unfit for business purpose, but developed according to the spec, might have 0 bugs. Or you might have something that has like a ton of bugs, but is delivering an insane amount of value. And he was like, no. And I started arguing with that person. It turns out he was the managing director of the whole kind of outfit. And I just said, basically, good luck with this. And I think one of the key things that for me was a big mental shift once I started building my own products was to look at how and what we measure as quality. And one of the things that kind of I started noticing in my thinking is that really there's 2 types of indicators we can talk about. And there's 2 types of metrics we can talk about. There are metrics that are diagnostic metrics. They tell us that something is wrong, but they don't tell us that something is right. And there are metrics that are value metrics. They can tell us that we are actually kind of doing good stuff and delivering value, but the value metrics are usually really, really difficult to capture. It's difficult to agree on value metrics. It's costly to measure and all this other stuff. And then we end up looking at diagnostic metrics instead. So diagnostic metrics are usually very, very quick to measure, and they can point out to some typical problems. For example, a thermometer allows us to do a diagnostic metric on human health. Do I have a high temperature or not? If I have a high temperature, something's probably wrong. If I have a normal temperature, that doesn't mean I'm healthy. It's just these types of problems are not there. Maybe there's a million other types of problems. And kind of it's very, very dangerous to try to optimize a diagnostic metric, because then we can get totally misled by what we're doing. So blood pressure is another kind of good example of, a diagnostic metric. You have high blood pressure, it's not good. You chop somebody's head off, low blood pressure immediately. Does that make them healthier? Probably not. And kind of optimizing for 0 bugs kind of gets people to game the system. It gets people to not test parts where they shouldn't be looking at. Optimizing that creates a very slow change to the system because people don't want to introduce bugs, and we kind of overdo other stuff that we shouldn't be overdoing. So we're going to come up with 4 rules for like how do we make software quality really tangible, something we can work with, something we can model. And the first rule is basically that the presence of quality cannot really be measured by the absence of something else, because absence of something is just measuring that we don't have something. It's not measuring that we have something else. And kind of bugs are really measuring the absence of something. They're measuring the absence of functionality in some place, or they're measuring some other thing. So we need to kind of come up with potential metrics around this other thing as well that's more direct. And again, diagnostic metrics have their place. They are cheap, they're easy, they can point out to typical problems. It's perfectly okay to look at them, but we cannot prove quality just because something doesn't have bugs. Maybe nobody tested the system. Maybe the system was untestable. Maybe the test cases were all wrong, so we didn't catch this. So this kind of 0 bugs is really, really weird. And I kind of from that perspective, we need to start thinking about, and when you're modeling this thing for yourself, what's the presence aspect of it? Even if it's horribly complex and expensive to measure, there's ways of reducing that, but we need to identify what these things are.
So what types of quality are we after? That's a discussion I've had several times with several types of stakeholders in several types of projects. And there is actually a list. I will show you. These are the index cards I created from this list of quality characteristics. They come originally from James Bach, and then the group of testers put together them in a long list of 180 different types of quality characteristics. So, for example, testability, capability, portability, performance, etc. So there are 180 of these different types of quality. And which one are we after? Which one are we targeting? So I was in this project with a small startup, and I was there as a consultant, and I was having this discussion with this founder that, what is important for you? Well, obviously, as a startup that, looking to scale, we need performance. That's all he had read about. That's all he cared about. And the product that he was going to build, or we were helping him build, was actually around indexing lots and lots of information for companies so that to make it searchable. And so we got into the argument of, is performance the most important thing? And it turned out, well, indexing data for reading, obviously we can't tamper with the data itself, right? So data integrity actually became a thing that kind of had to balance out the performance. And so we had to be really careful with the data integrity part while performance was still important. But putting them side by side on the index cards, actually I made him choose data integrity was actually more important than performance. So just making it more explicit, making the discussion much more concrete will help drive that type of discussion. I was in another project. We were building a CI/CD tool. You may know it. And we realized that we want to build a system that is fast and reliable. So obviously, building a CI tool, we need to give developers fast feedback. What we had to think about was, where can we make the trade-offs with fastness? And so when it comes to fastness, we realized also that it's okay that some parts are really fast synchronously, while other parts may be eventually consistent. Eventually consistent to the point where, all right, so if I have a summary of my builds, it's okay that loads a little bit slower than actually getting the feedback of the build. So we came to the conclusion that eventually consistency was a trade-off that we can make. And this is where we get to actually what we said was tangible quality rule number one.
Okay, mine was 0 then, okay.
Yours was 0. Don't think about quality, but think about different qualities.
And I think this is really important because kind of it helps us start deconstructing this monolith. And it's not then a question, does it have quality or not, but what kind of qualities does it have? What kind of qualities should it have? And this is where we start getting some really interesting philosophical thinking. For example, what kind of qualities should an accounting software have? Well, it should be trustworthy, for example, because if you can't trust the data, then you can't do anything with that. It needs to be reasonably fast. We're going to create these reports usually once every 3 months or so, and it shouldn't take 3 months to do a report, but if it runs in 5 minutes, probably fine. Not as much as kind of other things. But then, should an accounting software be beautiful? Oh, you're waving your hand, but like Xero, for example, is now one of the most popular accounting software packages in the world. And they started literally their it's no longer their headline, but it was like beautiful accounting software. So that was the key sales point. And in that case, beautiful doesn't mean like this wonderfully artistic website. It's just meant like nice colors that people are not going to be not gray and dull tables, but kind of slightly nicely designed. But that's what beautiful meant for them. And again, what is beautiful enough there? That's kind of interesting. So from that perspective, really, this is something that we need to start thinking about more systematically and think about different aspects of this. For example, like in video games are famous for like surviving bugs. You can have as many bugs as you want in a video game, but if it's fun to play, it's going to sell amazing. If it's not fun to play, it really doesn't matter if it has bugs. So people will create there are forums online where people will share information like, don't touch this door on this level, the game crashes, and that's fine. And there's kind of bugs that actually become part of the product. There was a famous bug in Civilization 1 because they used a unsigned int as measurement of hostility. And Gandhi starts kind of very peaceful and becomes more peaceful over time. But because they used the signed int, there was kind of 8 bytes and then 8 bits. And then around 1800 something, Gandhi becomes so peaceful, he goes into the negative and starts launching nukes at everybody. And this was such a fun thing that basically, it was a bug, but from that bug, it was so lovely and such a good thing to do that all the civilization games since then have this thing as kind of part of the product. It's famous for that. So kind of, we need to figure out, how do we even, what are the qualities we look at and where do we approach this stuff?
So that was this one.
That was that one. Okay,
so with taking what you said into account and all the different types of qualities we need to think about, and we need to make trade-offs between them, and that is essentially not a developer's decision. It's not a tester decision. That is a product decision.
Yeah, product people need to be involved. We need to, work out what are these attributes, what are these qualities, how much of this or how much of that, and when we make trade-offs, how real-time is real-time, how consistent something needs to be, how trustworthy. I mean, even for an accounting software, it needs to be trustworthy, but are you actually auditing people's books, or are you trusting the data they put into the system? There's always a line there that we can decide where do we stop on that line, and for each of these things, there is like a level that we need to reach.
And that comes back to the same thing when we comes to the CI tool that we built. It was okay that we were eventually consistent, but still there needs to be a limit to the slowness that we can accept. So we need to think about what is eventually enough. Is it enough that it loads within 5 minutes, 10 minutes, an hour, a day? Maybe not. Maybe 5 or 10 minutes. So that's how we actually decided what is good enough, and that would actually help us decide on some of the scaling rules, some of the ways we built with queuing systems, etc. Right?
So once you start asking this question, then it becomes really, really tricky because different people are going to have a different opinion. You work with one stakeholder, they say, well, it needs to be real time. Another stakeholder is going to say, it's okay to be within 2 hours. And then somebody's going to say it's okay to be within 5 minutes. And then the real question is, how do we extract this information from people? And how do we know that we've extracted the correct information? So there's good news here. And the good news is that this information actually does not depend on you or your stakeholders. So you can actually go and look for an objective opinion. And kind of, there's a really good technique I actually stole from Øredev a while ago. And it's a presentation that kind of Siggy and I had a heated discussion in a pub after.
Well, let me put it this way. We were sitting next to each other, and he was my professor at Lund University, Björn Regnell, showing this model, and I was like, I don't understand this. I was new to the industry. What he was saying just went all over my head. I did not understand it. And next to me, I was like,
"Fuck! This is like the best thing I've seen in the world."
And I could not understand why he was so excited. So tell us about this model.
So kind of first of all, and you definitely should watch. I think there's a video of that on, from Øredev 2009, whatever. You should watch that. But so it was presented by Björn, who was Siggy's professor at the university, and it's very academic because it's kind of presented from a university perspective. So there's like a really complicated graph and lots of labels and things like that. My brain doesn't work like that, so I came up with this version that's much simpler. And the model is called Cooper. It comes from Ericsson, I think, originally with kind of quality, usability, performance, engineering requirements or something like that. And it basically explains how to get, it explains a lot more, but it also explains how to get to the numbers I mentioned. And I think that's the beautiful part of it. You can kind of ignore everything else. And it talks about how in any kind of, I guess, IT project, product work, there's kind of some, cost benefit to improving things. So, your phone starts in a second, or your phone starts in 2 seconds. And to get the phone to start at all, there's some initial investment there to be made. And then you've built this technology, you can optimize it a bit, and then it scales, and at some point you hit the limits of technology. The phone can no longer start in less than half a second because the components are not good enough, or something like that. Likewise, how quickly do we handle requests? How much do we synchronize? How eventually consistent is this? Well, to get it to even be within a day, we need to build a database, we need to build a lot of stuff. Once we've done that, we can optimize the database, and then, because it's a batch job, in order to get it below 10 minutes, it's really going to be re-engineering. So there's an investment there. That's one aspect of the product. The other aspect of the product is kind of this benefit curve where they talk about having 3 points. And this is the beauty of it. These 3 points do not depend on you. They do not depend on your product. They do not depend on your stakeholders. They depend on the expectations of the market. And the 3 points are the utility point. That's kind of the point on the benefit scale below which your solution doesn't apply to the market. So if all your competitors have a system that synchronizes in less than an hour, your system not synchronizing in a day, you're not going to be able to sell it. When you get close to like 2 hours, it's okay. You can sell it. So then there's a point where it's called a differentiation point. That's the point above which your product is so much better than the competition that the clients will buy it because of that. So if everybody can synchronize the data within 1 hour, but you can synchronize it within 10 minutes, your salespeople can do that as like, this is a competitive advantage. And there's a couple of ways of kind of looking at this from different perspective. Kent McDonald in Stand Back and Deliver, which is one of the best product books, again, this is a product decision, talks about this being a billboard test. It's the point at which you start paying for advertising. You buy a billboard to say this. You put it on the product, you put it on your website, on the homepage. We do this so much better. And then the third point is the saturation point. That's the point above which the market is not ready for the improvements. If you can synchronize data in less than 1 minute, but the accountants can, only work in 15-minute cycles, speeding it up from 1 minute to 50 seconds, nobody's going to notice a difference. The market is not ready for the improvement yet. So maybe 5 years from now they will, but now improvements are kind of pointless anymore above that. So the interesting question is, when you have these qualities, like, what are these points for those qualities? And this depends on your competitors, this depends on your users, and you can figure out this out through user research, through kind of market analysis, and then we can have a decent discussion with the stakeholders, like, okay, eventually consistent for invoicing data. Do we ever need it to be above this point? Do we need to be better than the competition, or do we just need to be good enough? If we're going to be better than the competition, how much better? Do we need it to come close to the saturation point? Is that a key advantage, or does it need to be somewhere over there? And we can have much more structured discussions about how much really there. Plus then we can sequence releases. We can say, look, release 1 here, release 2 there, release 3 over there. And we can plan this on a much higher level.
Thank you.
Oh, shut up, sorry.
So I'm going to tell you a story a little bit about, I started IKEA a year and a half ago, and if you don't know this man, this is Ingvar Kamprad, the founder of IKEA. He's passed away. But before he passed away, he wrote this little book, The Testament of the Furniture Dealer, that kind of emphasizes and encapsulates what he thought, his thoughts on IKEA is, IKEA culture, and IKEA products. And when my first week started reading, I got to the chapter about quality, product quality. Obviously, that's about the physical products, the furniture that we sell. But at the same time, I realized how well it actually fit into my worldview of software and software products and software quality. So he writes that throwaway products are not IKEA. IKEA products must be functional and well-made. So basically, he emphasizes how important it is that things are good enough and fit for purpose. Another section that where he describes quality is about quality must not be an end in itself. It must be adjusted to the consumer's needs. So basically, this is the same thing that we're talking about here. Consumers' needs and how much consumers are ready to pay for a product is the same for furniture and software. So basically, he takes the example of a shelf in a cabinet, a kitchen cabinet, or a shelf in the Billy bookshelf, or a shelf in the wardrobe. All of these shelves serve different purposes, and thus have different amount of efforts put into the work for it, and thus affecting the price. So obviously, more effort into a product gives a higher price, because that's how products are sold, right? So more effort, a higher price. And what he points out is that different products that serve different needs can and should be sold at different prices because of this difference in effort.
Plus, I guess you need to invest different levels of effort into different things, and that's kind of justified. So that kind of framework really starts helping us make a decision, like how much should we do here, how much should we do there. But that's still all about how much we are doing, and that's not like the level of quality. That's not all about quality. There's one more level there. We can have amazingly good work delivered from our end, where kind of some other factors cause stuff that is really, making the product almost no quality. So there's this wonderful example that kind of a couple of years ago of a technically perfect product, almost perfect. They kind of engineered to perfection. They were talking about this, singing high praises, how well the components are made, how precision design, and how beautiful it looks, and how well it works. And I think that the company itself got something like $150 million investment to build this stuff. And they built this amazing kind of juice machine where they were going to basically sell subscriptions for juices. So you buy the machine was costing something like $400 originally, and then you buy a subscription to kind of juice packs. And the whole business model was that they're going to sell the machine cheaper than it takes to make, and then sell juice packs, like printer manufacturers are doing that. But it turns out that kind of people can just squeeze the juice out of the bag. And they get the same result as buying a $400 machine. And then nobody wanted to buy the machine anymore when they kind of figured that out. So there's kind of, it doesn't matter how perfectly something is made, where it's pointless, or people can, get the same value some other way. And that's where all this kind of, we need to figure out, is it well made? Is it good enough for all these different purposes? Is it useful to people? Are people getting the level of value they expect to get from it? And ultimately, is the company getting value from this? Why are we building this stuff? And should we be building this, or should we be building something else? There's a couple of models that you can start looking there. One model I quite like is described in a book, How Google Tests Software. And it's I'll give you kind of a slightly oversimplified version of it. You should actually read the book and look at some of the talks that James Whittaker did on this a while ago. But effectively, they were trying to capture a holistic aspect of all this stuff. And one of the things they realized is that risk is not in features. Trying to figure out the risk of a certain feature or a risk of a certain component is not easy, because the risk is not about features. The risk that kind of they're doing testing about is about disrupting user abilities or user capabilities. So if accountants cannot do a quarterly report, that's massive risk. And if, people cannot access their data, that's risk. So it's user abilities, user capabilities, and they created this matrix called the attribute component capability matrix that is basically listing all these kind of qualities that we want to get and we want to kind of put trade-offs on. Then they're listing components of the system that the system is distributed over, and then inside each box, they put in a bunch of user capabilities that this component participates in, that makes the system fast, secure, fun, whatever. And then what they realized is they can actually score the capabilities based on risk, and then decide how to test, how to manage different components based on the level of risk that they carry, and how to apply different practices. So they would score something like 1 to 20, I think, in the book. And then they create policies like, okay, for anything that has risk level 17 or above, it doesn't matter how much automated testing has been done, somebody needs to manually look at every single action on the screen. For risk levels, 10 to 15, it's fine to kind of just look at it when it changes. For, and things like that. So we simplified this significantly for a product I was working on, and we just gave it like 2 dimensions. What's kind of the business criticality of it, and what is kind of the frequency of change. And if it's kind of low on both, we had a 0-1 score. So if the total score is 0, then all we do is automated testing. If it's 1, then we'll do all the kind of unit tests, acceptance in an automated way, but we will test it manually, explore it when it changes, but not when it doesn't change. And if it's 2, then we're actually going to explore it every time anything else changes. And with all the automated tests. You can create different policies for that.
You got the next one as well. So
no, I spoke too much. Sorry.
So another model that Gojko actually created himself, and this is the model I took to my heart 10 years ago when he published this blog post. He describes Maslow pyramid of needs. And so basically, Maslow pyramid of needs for software products. So on the bottom, obviously we need to satisfy the most basic needs of deployability and functionally okay. So basically, the software needs to run somewhere, deployable, so we can deploy it and run it somewhere, and it does something. It is functionally okay, and it does something that is of meaning, right? And then on the next step up, we talk about performance and security. So performant as in, is it fast enough? And is it secure enough? So basically, for the purpose that it's created and the functionality is fast enough so that it's usable. So the next one up is usableness. So can the software be used by people? Can
the kind of UX testing and things like that going there?
Yeah. But it's not until we reach the next level of usefulness. So does the software bring the value to its users as intended to? So can they reach their goals? And the successfulness being the utmost value of why the software is created in the first place. So basically bringing in the revenue or the monthly or weekly active users or whatever the reason that we build this software product.
So I think before we move on to the next slide, one of the key things of the Maslow model, like for humans, is that once you've succeeded on some level, improving and investing in that level anymore does not improve your quality of life. And it's much better to kind of try investing in a different level. So it's kind of the idea with this as a pyramid is, if it's not deployable, nothing else matters. But if it's deployable enough, investing in better DevOps doesn't improve the product. Investing in more usability or investing in performance improves the product. Once it's performant enough, optimizing performance more doesn't really deliver value, but looking at UX, doing other things, and kind of all these things build on each other. And it kind of, the idea that when working with this financial client is we would map out different levels of quality to these things and then have policies around who does what and when, how frequently, and how do we actually make sure that everybody's focused on kind of the realizing the purpose of this for the company that's building it.
Yes, and that to form a reasonable discussion about what qualities are we after. So I'm going to tell you about my current context. I am quality leader for this department at IKEA called IKEA Planning Experiences. So it's the department that builds and runs all the planning and configuration experience that you can see online and in the stores. Basically, configuring your wardrobes, like here in the PAX planner, and configuring a sofa, building your kitchens, bathrooms, etc. Right? And so we're about 300 people working in 30 different product teams, and so all of these products serve different purposes and have slightly different prerequisites, and the goals of these products are slightly different. So I needed a way to kind of focus the discussion with people and teams on what things are important. So that's where I actually pulled in Gojko's model again, and it's actually the third time that I'm pulling it into my current work. And I'm going to share with you a slide. It's kind of a lot of text, yes, I know, but it's basically my way of mapping this pyramid of needs for software to our current context in planning experiences teams. So basically, if we look at the bottom, basically deployable and functional okay being measured as failures and bugs, reliability and availability. We're measuring the basic DORA metrics, so mean time to recovery, deployment frequency, change failure rates, change lead time. We're also monitoring error rates. So these things obviously give some sense of how we're doing, but we should consider that this is on the most basic level of quality, right? So not until we have our bases covered on this level, we can strive higher up. And then if we look at fast enough and secure enough, there are obviously standard ways of measuring performance. Google Web Vitals. You can also measure perceived performance, because perceived performance is actually what users perceive when they're using the software. So while your first page load may be slow, if consecutive page loads are fast, you get a better perceived performance. So that's also a way of looking at how what type of performance we're after. Can it be used by customers and coworkers? We're measuring engagement rates, so bounce rates. How often do people come and leave directly? And we're also measuring some customer interaction moments. So, for example, different types of things that a user can do in their user journey, where we understand their intentions. Obviously, there are a bunch of other things that we can measure there, as well as session times, page level insight, different things there. And if we come up to the usefulness, so basically our end users is customers and coworkers, and how well do we actually satisfy helping them reach their goals of furnishing their homes, or helping our customers furnish their homes. We can look at some of the conversion moments, so save or put to cart, etc. Right? But this is also something that can be measured by NPS surveys, for example, if you have those in your different companies. And
sorry, I just want to point out a really important difference, because we're throwing a lot of terminology at people. So sometimes people get confused with the difference between useful and usable. And kind of with the usable level, we are measuring that people can potentially get value out of this. We can do that before we deploy software. I can do some, UX testing. I can put a button there. Can the user get an export if they click this button? Yes, they can. I can prove that. But is it actually useful? We cannot measure without exposing it to real users and measuring the value they get. And there's a big difference really there. One is measuring whether we've built it the right way. The other is measuring, are we actually building the right thing? And that's kind of the big difference there mentally.
Yeah. And a couple of other things that we can measure, and we're not completely there yet with all these measurements. And but for example, planner efficiencies. How quickly do we help people reach their goals? And then successfulness for us is obviously about supporting IKEA with serving customers and selling furniture. So obviously revenue is a big part, but also supporting the running business by supporting our range updates and our brand value and things like that. And so to form the discussions with the different teams, I've put together this quite long list of things that we can measure, and it doesn't actually, all of these things doesn't actually really apply to all teams, but at the same time I have given teams direction in terms of how to think about their case and their quality. And just like you mentioned before, what we want and what we strive for, we want a good enough or a decent slice of this pyramid. So we want to reach good enough on each of these levels. And what I'm actually aiming at and what I want to see is when we want to strive for better successfulness, maybe actually tackling some of the performance issues, because that's what is shown in our measurements that affects successfulness at the moment. And so it comes to tangible quality rule number 3, shape the quality priorities narrative with the model so that you can actually have these discussions and form these discussions with the teams.
And kind of the model it doesn't need to be the model Sigge showed you unless, your business is about building wardrobes, probably will not.
We are a bit short on time, so we need to...
Okay.
No, I'm just telling you.
I can
stories.
Go, man. This is
we got a couple of more minutes.
That's okay. So what I was going to say is kind of one really important thing there is kind of create your own model. But once you create a model, you really need to measure in one way or another whether you are consistent with the model. And whatever the decision was, look at whether you're consistent with the model. One book I recently read that's kind of phenomenal called 4 Disciplines of Execution. Everybody should read that book. Has a kind of research, and they're looking at companies that are really, really good executing on their plans compared to companies that are not. It's not a software book. There's kind of 0 cases about software, but I have this wonderful terminology that they kind of talk about in the book, and I like it because it gives me the kind of clean terminology to have arguments with people. So that's why you should read it as well. And one of the kind of lovely statements that I have in the book is that if you're not keeping score, you're not really kind of competing, you're just practicing. So we have this model, but are we actually keeping score to see, are we consistent with the model? Are we not consistent with the model? Are we exceeding it? So keep score in some way, and that's kind of really the last rule we're going to talk about. Is make, once you have a model and you've agreed on something, really kind of visualize and quantify it, measure it, and show it to people. What they talk about in 4 Disciplines of Execution is how important it is to create a compelling scoreboard. Because when you have a scoreboard that's in front of people, you can delegate decision making, you can put it out, people can work much better on their own, and they can actually kind of speed things up. So one thing that I quite like, and this is not a picture from kind of Google, because I didn't want to show a copyrighted picture. I've created my own that looks similar to that. You can see the original one in Whitaker's presentation, is what they do with kind of the ACC matrix. So once they've decided on all those levels of risk and integrated the matrix, then they basically figure out how much testing they need to do and what type of testing, and they're tracking whether that's done. Whether you're doing manual testing or automated, that doesn't matter, but they have this visualization of the matrix on the top, and the depth is basically the level of risk a product carries at any given point. So if we do some, we see this area like the account panel is, the performance of the account panel is not good, then we can, or not proven, we can do some de-risking there with manual testing, with load testing, with automated testing, whatever, that kind of fills this hole up. And this allows them to have policies around how much risk can we carry in production. Faster delivery has value, and speeding up the delivery has some value because of time to market. At the same time, we don't want to release stuff in production, it shouldn't go there. So they have a policy, say, this is 1 to 20. They have a policy that when we have de-risked everything up to level 5 or something like that, it can go live. We'll deal with the other stuff, we'll deal hot fixes and things like that. Again, this is all about figuring out the risk and visualizing it, and then you can really kind of quickly go through this and make better decisions on your own if you visualize it with something like this.
And obviously, when you've visualized something like this, you need to feed it with data. You need sensors to know where are we and where do we want to go and what do we need to do to actually get to the green field here. So this is obviously a quite overwhelming picture, but it's basically our last one, and it's basically a talk in itself. But I've started
stay here for the next 1 hour.
Yeah. So I've started to have discussions with teams on how much investment do we want to do when it comes to testing, test automation before releasing anything, or which risks are we actually okay with deploying to production and risk having them impact users in production. So this, you can see here the to the bottom here, that's the standard test automation pyramid with unit test, integration test, end-to-end test, and then you got the manual testing in the cloud. And then I've added to this hourglass model health checks, alerting, monitoring, logging, and where and when do you want to do these types of activities. And what I want to emphasize and end on is actually think about which investments do you want to make before releasing. Before you can realize the value to your users of what you've built, and what risks can we afford to just pick up in logging or alerting, because when we see that things go backwards for users and we are quick enough to fix those things, the impact may not be too big.
And for some levels of risk, brilliant. For some levels of risk, unacceptable. And that's
Yes.
kind of the whole thing, coming up with the model. So kind of to kind of finish this thing off, I think we're going to give you like a single slide to take a photo of if you want. Like the key things to create really a model for yourself are, first of all, think about, not having a single definition of quality, because that's not going to work. Like there will be different qualities, and then kind of we need to figure out what those are.
And then we need to talk about what qualities we care about and which ones where we can do trade-offs. And trade-offs, that's where a product team and the product manager needs to decide where is it okay, where is it okay to make a trade-off, and what can we live with. And then when we have priorities, we shape them with a model.
Yeah, and I think kind of that's really, really important, because this information needs to be consolidated in some way. And then you coming up with your own model, whether that's kind of, a matrix or a pyramid or who knows what, it helps you kind of have this discussion once and then update it over time, but not have to discuss the whole thing over and over again every week, every release. And it really helps guide this whole thing. So, and then finally, I guess,
measure and visualize. We're
Done.
done now.
Thank you very much.
Thank you very much for staying.